manual tools, and we have traffic signal optimization tools. We have travel demand models. We have macroscopic simulation models, mesoscopic simulation models, and microscopic simulation models. So we have 7 kinds of tools we can use. In order to do a project right, we have to select the proper tool. Let's take a look at the first one. Sketch planning tools. Sketch planning tools is either spreadsheet-based or GIS-based. They are very, very simple. Okay? And let me just show you what it is. Here I listed many examples. Let me show you what, for example, this one is. This is just a Excel spreadsheet. So you fill the table. It has some automatic calculation, and it will give you the results. This is called sketch planning tool. So it's very simple. So you can do it by yourself. Okay? And we have already several tools you can use. You can check out the website. But essentially, they are just simple calculations. So they are both very cost efficiently and very hard to present. So if you have an Excel file like that, and how can you expect to present a lot of things to the end users or to the contractors? So this is an effective way if you are experienced. So put this in mind. This is a possibility. Then the next one is called HCM-based tools, Howe Capacity Manual-based tools. Howe Capacity Manual is a manual that is very important in transportation, and it's published by the Transportation Research Board. It has already 2 or 4 versions, respectively, published in 1950, 65, 85, and 2000. And now the version we're using is the fourth version, HCM 2000. And the latest version called HCM 2010 is coming. Okay? And we can access this website to buy it. It costs only $110, but it's very thick, so I think it's worth it. And this manual contains a lot of formulation. It contains a lot of functions and methodology that I can use to analyze the urban network, especially for those intersections, the road segments. There are a lot of things you can answer. So this is one tool that you want to try. And in order to calculate them, this University of Florida, it has a transportation center called MacTrans, has already developed this Highway Capacity Software 2000. So you don't need to buy the book and write a program by yourself. You can use this Highway Capacity software. Okay? So that's the second choice. The next choice is called traffic signal optimization tools. These tools are especially used when you want to optimize the signal timing or phasing plan at an intersection, and signalize the intersection. And here we have several alternatives, which are very popular. Okay, in Adele's class, traffic operations design, you are going to learn Synchro. You are going to learn how to use it. Synchro has 2 models. One is based on Highway Capacity Manual. The other one is called ICU, Intersection Capacity Utilization Model. So these are specialized in the optimization of traffic signals. So the next one is called the travel demand model, or 4-step models. These models are used to estimate or to forecast the travel demand. Travel demand means the travelers. Okay, it has 4 steps. It's very traditional in transportation engineering. So I think I'm talking about this only for you who don't know this. The first step is called trip generation. In this step, we want to get the number of trips, either both to and from each zone. So we divide the whole network into several zones and by their functionality. For example, this zone is about employment. Another zone is about housing. So in this first stage, we want to get the number of trips generated or attracted to each zone. Then the second stage is what's called trip distribution. In this stage, we want to get an origin destination matrix, which represents how many trips are from each zone to another zone. Okay, so for each OD pair, and OD pair is a pair of zones. So for each OD pair, we get a number of trips between them. And in the third step, we get a proportion of each travel mode between each OD pair. So in this, after we get the OD matrix, actually would mean the total number of trips between this OD pair. Then we want to divide the OD pair into several travel modes, like transit, passenger car, like bicycles, like that. And in the last stage, traffic assignment, we want to get the path or route assignment for each single trip. So we know how many people are using like what kind of mode from one zone to another zone. But in the last step, we want to assign the specific path to it. Okay, so what roads they are using. This is the traditional four-step travel for demand model. And if we run the travel demand model once, it will not be called a simulation. But if we divide the time into several slices, and at the beginning of each time slice, we run the travel demand model once, then we get macroscopic simulation models. Here is a list of the alternatives or the popular models, popular software packages you can buy. The first one is the most famous one called Transcat. We also have Resume, Cube Voyage, AMI, and Omnitrans. So, do you have any question about what macro simulation is? I think in the first lecture I talked about it. Let me review it. So macroscopic simulation just means, in your eyes, there is no single vehicle. You see traffic flows. Okay? You see traffic flows. And the traffic flow is runs different from time to time. Okay? The next type of simulation model is called mesoscopic simulation models. I think some of you may have already forgotten what it is. So let me emphasize. Mesoscopic means you still see vehicles, but the vehicles are not moving by themselves. They are moving like a boat floating above water. So the thing actually moving is the flow, but the flow carries the vehicle. Okay, this is mesoscopic model. But it doesn't mean that the vehicle doesn't move by them, moving in a very ordered way. It's using a Boltzmann Boltzmann type equation, which are used to model the movement of particles inside a flow. So you will still see vehicles moving relatively forward or backward within the flow. And here are some models you can choose, including Resume, also Dynasmart, Dynasty. Okay, some of you have already suffered from Dynasty and EMSA, Cube Avenue, and Mezzo. Here I want to emphasize Mezzo because it's open source. Another important thing is this institute, Royal Institute of Technology, actually is very famous in the field of transportation. And you have to know that Royal Institute of Technology its acronym is KTH because it's Swedish. Okay, so KTH means this institute in Sweden. Here are some models you can choose for mesoscopic. And the last one is microscopic simulation models. For these kind of models, please refer to lecture 1. And I want to supplement one thing. called cube dynasty, okay, from City Labs. This is also very famous, but I didn't mention it in the first lecture. So now I have already explained all kinds of models. I don't know if you already understand them very clearly, but let's talk about how, which ones we should choose. Okay. So I already introduced them. So now, if for example I want to design a project, for a very big area, like the New York State. I want to design, for example, like interstate systems or arterials in the New York State. And in this case, we don't need to know the vehicle movement at a specific time, right? We only need to design it. I mean, in a macroscopic scale. So we will use either travel demand models or macroscopic simulation models. And if we want to design something for an intersection, we may want to use highway capacity-based tools or traffic signal optimization tools. But if we want to track the emission, for example, track the emission that vehicles produce around an intersection, around a certain intersection, then we may want to use microscopic simulation models because they are going to give you more accurate trajectories. So here are some simple examples. Do you have a question about this? I don't think I explained this very, very clearly, but ask yourself. I mean, after you understand what each tool is, ask yourself how you can use it more appropriately. And I would encourage you to try or to take a look at the software packages I listed. I think that would be beneficial for your future career. The fourth task is to define the scopes. I use the plural, scopes, because we have two scopes, geographic scope and temporal scope, two scopes. For temporal scope, we mean we have to understand three things. The first thing is the opening year, which means the year that this project is finished and is open to the public sector. Design year is, for example, if you have a bridge and you want it to last 20 years, then the design year will be 20 years after the opening year. And sometimes you have to focus on the interim year, which is the year